going to present about what are capabilities about our 3D printing and 3D scanning and other services that we provide to in different applications in different domains. And I'll share with some what technology, some demonstrations of the technology, materials, and rest of the things. So we'll begin the session now. So today we are going to talk about our services and the capabilities that we provide and that we are providing into the industry since last many years. And today is the first time that we are presenting our services to all of you. So just to give a small introduction about us who are new, who are first time joining with us. So we Altem Technologies, we are the 3D innovation platform company where we are associated with many of the software and the hardware solutions provider. So we provide the solutions in a complete product lifecycle management, and we provide the products and the services into these categories. Starting from the Dassault systems, where we provide the CATIA and the 3D experience platform, even the Dell Mia for the manufacturing simulations by the Dassault systems. Then coming on to the simulation side, we provide solutions from MSC software. We use the Nastran, Adams for the fluid dynamics or for the manufacturing simulations. Then coming on to the 3D printing services, we provide solutions from the Stratasys, where we provide the plastic 3D printing by using FDM, PolyJet, and the SLA 3D printer. Then we have the Artec 3D scanning solution, reverse engineering and scanning solutions. Artec 3D is a global and the most renowned 3D scanner platform company. And we are providing this solution into the industry. And this Artec 3D solution is a very fastest and handheld 3D scanner. Then coming on to the life sciences simulations, where we want to do the some medical research or drug discovery research, we are associated with Dassault Systems, and the product is Biovia. Then coming on to the our new addition into our portfolio, which is a cell link life science, and we provide a 3D bioprinting with the 3D bioprinting, where you can do the tissue culturing or tissue cell culture or 3D bioprinting for the tissues or for the cells into a control environment. We have started since 2011, and we have completed 10 years this year. And since then, we have been able to bag many of the awards, starting from our India Small Giant Award in 2013 by MSME, then various award by the Stratasys as a strategic partner award globally. And we have been awarded as the most innovative 3D printing company in India by Frost and Sullivan. And some of the various awards from the Stratasys as a top customer adequacy and highest business growth award. These are our customers partial list where we have provided the solutions and where we are serving through our services also. So we are providing the services and the product solutions into various applications, into various domains into the industry. And the product categories that we have, so we have been able to provide a wide range of solutions into all of the domains into the market, like in the automotive OEMs, in automotive suppliers, aero and defense, educational institutes, in healthcare, also in IT services, and also into the consumer products company. So we are talking about the technology and services that we provide. So we provide into four categories, into two categories. So we provide the solutions into 3D printing and 3D scanning, and also we provide the solutions for batch manufacturing by using the vacuum casting. So, what are the manufacturing challenges that we have faced or we have observed through our customers? Is first of all the cost to build. So, the fabrications and the assemblies for the on the manufacturing line, it costs a lot by using the conventional methods, and it is very difficult and it is very hard to keep the margins on those manufacturing costs. And also the outsourcing cost also raises. into different domains. So by using the conventional methods, the outsourcing cost also increases, and also the fabrications and the assembly time also increases if you make the parts into number of assemblies. While in the 3D printing, we'll talk about what are the benefits that we get against these challenges. Also, the second point is the material side. So the materials for the like for the tooling applications, if we talk about on manufacturing line, then for the jigs and fixtures, steel and the aluminum are the most useful, the mostly used tools. But these are also the heavy material tools. But we have the cases, we have the customers who have been able to replace these material tools, these metal tools on the manufacturing line, and now they are using a 3D printed tools on the as a final end use part. The heavy materials, which are the solid blocks, are very or which are large tools, are very risky by the employees, and it raises the risk of the safety of the employees also. So sometimes also that as per the design, as per the complex designs, it also not able to meet the operator needs. So because of the lack of the design knowledge or the weight size or the shape of the product of by the production errors. So due to that, the due to the operators demands does not meet. So it raises the issues on the manufacturing side also. And coming on to the productivity, so if the tool is very large and it also very heavy, so it does not make a very good ergonomic design. It does not provide a very good safety for the employees on the manufacturing floor. So this is one of the challenge on the productivity side, and it decreases the productivity. And also the spare parts lead time. So if the lead time increases, the productivity decreases on the manufacturing side. And also the automation sites, if we are using the heavy tools on the automation or on the manufacturing lines, then also due to the poor ergonomics, it increases the lead time, and it decreases the efficiency of the employee also on the production side. And coming on to the most important most important thing is the lead time, that how much time you are taking to produce or to meet the production demand. So because of the heavy or the large jigs and fixtures, which does not meet or which does not provide very good accuracy, or which are very heavy to handle also on the on the manufacturing line. So because of that also, because of the poor ergonomics and more manufacturing time, it takes a lot of time to produce the parts and to meet the production demands in the real time. So that is why we are proposing here the 3D printing solution here, where we can uh, reduce all these and we can decrease or we can cater all these challenges. So 3D printing is a manufacturing process where the final object is produced by the deposition of material layer by layer, and it construct the whole geometry in a very controlled environment with motion control components. But there is also one more term in the market, which is additive manufacturing, and people get confused between what is 3D printing and what is additive manufacturing. So additive manufacturing is a process. So 3D printing is a process within the additive manufacturing. So additive manufacturing process involves complete end-to-end solution. So we start from the design. So for design, we provide the solutions from the CATIA, where you can create the designs, and you can also optimize those designs into the softwares by using our additive manufacturing modules. Then coming on to the simulation side and the pre-processing, we have the solutions from the MSC, where you can simulate your designs before going into the 3D printing process. Then comes your 3D printing technology or 3D printing process, where you manufacture your part. So 3D printing is a process, is a part of the additive manufacturing solution. After 3D printing, you can do your post processing, you can enhance the finishing, or you can also increase its strength into the part. So we also have some post processing techniques and methods where we discuss that later. And after post processing, you will get your final part. So this final part can be utilized as a prototype part or also as an end use part also in a final application. So in additive manufacturing, you have to choose your correct design techniques. You have to choose your materials which fits for that particular application. You have to choose. You have to select your printing process and also your pre and post process methods for the success of that particular job. So as you can see in the photos, that how by using the 3D printing, how by using the additive manufacturing process, by design optimization, how you can reduce the material consumption without compromising its strength, and you can reduce its manufacturing cost and its lead time. So by using the additive manufacturing, you can reduce the cost of manufacturing in compared to the conventional methods by 40 to 90%, where you can make the complete part into one assembly, which reduces your part consolidation time or assembly times. And also it brings your in-house capability to fulfill these requirements. By using the engineering grade thermoplastics that we provide, we have 20 plus individual FDM materials, FDM thermoplastic materials, where by using which you can replace your heavy metal parts on the manufacturing line or for the prototyping methods, and you can reduce the weight of the product by 3 to 7 times. You can modify these parts, so you can modify the infill of the materials into these parts by using this technology. Also onto the ergonomic sides, and also on the health and safety sides of for the employees, it reduces the safety issues, it improves the ergonomics, and it allows you to make the customizable geometries to meet the operator needs. Also on the productivity side, since we are using the light grade engineering grade thermoplastics, lightweight materials, and also we are improving the ergonomics for the health and safety of the employees. So it reduces the cycle time, it increases the productivity for the employees. You can adapt the design for additive manufacturing, where you can optimize your designs and you can reduce the manufacturing cost and the lead times. And also, as we talk about the lead time, so you can reduce the lead times from weeks to days, where it takes like 3 to 4 weeks amount of time to produce one tool. You can make the similar tool in-house with the 3D printing, or you can outsource to us as a services to us, where we can reduce the lead time for you from weeks to days up to 95%. So starting from our first technology where we provide the solution is the fused deposition modeling, where we use the thermoplastic materials in the filament form, and this materials is preheated to a semi-liquid state, and it extrudes the materials by a computer controlled tool paths to build the part layer by layer. So this is a small demo video of how actually the technology works.
The part. Similar to a hot melt glue gun, uncoiled material is slowly extruded through dual heated nozzles. The extrusion nozzles precisely lay down both support and thermoplastic material upon the preceding layers. The extrusion nozzle continues to move in a horizontal XY plane while the build platform moves down, building the part layer by layer.
So you have seen that the filament material, it comes into the extruder head, and we use the dual head nozzles, one for the model material and one for the support material. So the support material is the water soluble or the dissolvable support material, and it supports your geometry while it is printing, while it is depositing the model material on the build platform. So on the material sides, we have a wide range of materials in the thermoplastics, started from our thermoplastic elastomer, which is a thermoplastic urethane with a Shore value of 92A. So you can make the hose pipes or the bellow kinds of the profiles where you need the elastomer materials. So we have the now 3D printable elastomer material into our portfolio, and we have the standard plastics like the APS or the PLA or the ESA material, where you can do your general prototyping, and even you can use it as an end use part on your automation lines also. Then coming on to our more stronger materials, like we have the polycarbonate, nylon 12, nylon 6, ABS carbon fiber composite, PC-ABS composite, and Diran, which is a nylon mineral filled composite material. These are the strong materials which provides you the more engineering applications, where you want as an end use part feel, or the as an end use kind of the functional prototyping. during your product development stage, or even for your small batch manufacturing usage. You can also use these materials. So PC, ABS, Piran, and ABS carbon fiber are good materials for your small batch manufacturing productions. Then coming on to the high performance, where you need some very stronger, some more stronger materials, some more heat resistivity and chemical resistance. So we have the Altem 9085, Altem 1010, which are the aerospace certified materials, which is also fire, smoke, and toxic resistance materials, and also provides you good, very high thermal resistivity of over 210 degrees Celsius. And coming on to the more stronger material, which is a nylon 12 carbon fiber, which provides you very strong applications into your as an end use part for the automotive or for the aerospace applications, and even for the automation side. Then we also have a PET-based and the ESD-based material, which is Entero, which you can use for your chemical contact applications, or even for the storage, or for the mounting and the assembly of the PCB boards, or for your electronic parts by using the ESD material. The second technology that we have is a polyjet technology, which is a multi-material 3D printing technology. So in this technology, we can mix up to 7 materials at once, and we can create more than 5 lakh plus colors. And we also mix different combinations of the materials to produce good engineering parts also. So this is how the technology works. So from the small holes, the material drops onto the build volume, on the build surface, and the UV light. This is the UV curable resin material, so it cures the material simultaneously. So it also saves your time of saving or curing the material, post curing the material. So by using this material, we can create the styling parts also, for the aesthetic parts also, where you can mimic the leather simulation, wooden textures, and even you can print the clear texture parts which simulates your displays. So even for the automotive styling applications, this is a very useful technology. And for the engineering applications also, where you want some stronger materials, or if you want to mimic some flexibility, or if you want some good thermal resistant material, then also we can use this technology into that category. So we can start from your draft designs, where you can save the materials, or you can save the printing time. Then coming on to the render design, you can design after deciding on your final designs. You can render your part into CAD, and that similar render file can be 3D printed with the same materials, or you can say we can mimic the texture of those materials into different categories. So we have a 3D printing materials into various categories, starting from the rigid. So we have the rigid material into various color options: gray, blue, black, white, and also we can make the combinations more than 5 lakh plus colors by using the combination of cyan, magenta, yellow, black. We also have the transparent materials, which is ultra clear, which can provide the transparency of up to 90%, 90 to 91%. Then we have the flexible materials, which is the Agilus 30 material, comes in clear white and black color. By mixing of flexible and the rigid material, we can make the combinations into different shore values, starting from 27A to 95A. Then we have the special materials for even for the medical and for the dental applications. So for the dental applications, where you want some biocompatible materials for different applications like the clear aligners, or even for the different orthodontics and prosthodontics applications, then we can use these materials. For the medical applications, where you want to mimic the patient specific anatomy, we can use the exact materials, or we can use the materials like bone matrix, tissue matrix, gel matrix, or biocompatible materials, where the patient specific anatomy, that 3D printed anatomy, can mimic the exact feedback and exact biomechanical properties into that anatomy, which helps the surgeons, or which can help to the for the training skills also, or to make the training models also for the students and for the surgeons also. So by using the combination of the FDM and the polyjet technology, we can cater multiple domains and industries. like the UAV and drones, which are being very popular and which are increasing into the market. So the production and the manufacturing, or for the prototyping of the UAV and drones, we can use the combination of this technology for the robotics applications on the manufacturing line. For the smart factory implements, like for the end of arm tools, where you want some stronger materials to hold the parts for the manufacturing side. Then also coming on to the prototyping of the medical devices, for the final testing of the medical devices, we can use this technology by making the hardwares, and we can make the final end use products also. Coming on to the engineering sides, we can use it into the educational, we can use it in the engineering applications into different departments of automotive or aerospace. And also into the healthcare industry, we can use this technology for the pre-surgical preparations or for the training simulation models, and also for the simulation or uh, for the pre-preparation of the complex surgeries, where it is difficult to capture the data or to extract the data from the MRI and the CT scans, which makes it difficult, and which makes it difficult for the surgeons to study the anatomy properly before actually going into the operation. And also into the consumer industry, where you want to produce multicolored parts, like as you can see on your screen, that we can print complete packaging of the earphone models or the earphones, even into the consumer side, like the nail polish, or even for the shoe industries, even for the bottle making industries, or many of the consumer based industries. So we can use the similar technology, the combination of this technology, and we can cater all the solutions into the industry. In 3D printing, we can cater the most important applications are divided into three categories. The first is the rapid prototyping, where you begin with your product development, and we can do the design and the functional validations by using this technology, by using these materials. Then we can also use it on the manufacturing side, on the manufacturing floor for the rapid tooling, where we can bridge the gap between the prototyping and the manufacturing side. Also, we can use it for the custom manufacturing or for the rapid manufacturing, where you want to produce a small batch manufacturing of the parts, like 100 to 200 pieces of the parts, by using the 3D printing, by using the stronger materials like the nylon composite fiber, or the nylon carbon fiber, or the ABS carbon fiber composites, or PC ABS. So these are the stronger materials which you can use as an end use part for the small batch manufacturing. And into the industrial applications, so we can provide the services into the various categories. For the 3D printing, we can provide you the large prototyping parts, which like the front and the back fenders, for the passenger and the commercial vehicles. For the functional prototypes on the engineering side. For the design and production, for the interior styling and for the exterior styling, where you want to produce a transparent, opaque, or even the multicolored textured parts. So we can also make that by using the by by the use of the FDM and PolyJet. Then coming on to the jigs and fixtures and tools, we can make the patterns for the sand castings. We can make the fixtures for CNC or CMM, or for the automation lines. We can make the jigs for the greasing applications, for the product line automations, for the low and high temperature masking, which where you require the temperature up to 213 degrees Celsius. Even for the composite tool side, reduce uh, we can reduce the weight of the composite tools by replacing the heavy metal tools with the thermoplastic tools, which are compatible for the aerospace applications, for the aerospace part productions. Gauges, even for the replacement of the metal parts with stronger nylon carbon fiber material spare parts, and the production of parts in very less volume. Yes, so we also provide the, apart from the 3D printing application, we also provide the services in the by using the vacuum casting process. So this is how we combine the 3D printing and the vacuum casting process, and how we produce the parts by using the combination of two technologies. So this is a one demonstration video of how you can use the 3D printed prototypes or 3D printed patterns, and we can use these patterns into the vacuum casting process. So first we 3D print the parts by using any of the technology like FDM, polyjet or DSLA, and we can do some post processing on the surfaces by making it smooth and more aesthetic. To make the surface smoother, we can do the priming, painting, sanding, buffing, any post processing solutions. Then comes your mold making process techniques. So as you can see that they're making the mold. So we fix the pattern in the center, and then we pour the silicon mold material over the surface. And currently, this complete material is exposed to the air. So we put it in the vacuum machine for the defoaming treatment, where it extracts all the bubbles from the material, and it does not leaves any air bubbles inside the mold. Then after the vacuum process, we put it in the oven so that it cures the silicon material, which converts into the solid, stronger material. And now the second next step process is to make the parting line. So we open the silicon mold by making the parting line, and we can take out the pattern. And after taking the pattern, it leaves the cavity inside the mold, and now comes your vacuum casting process. So we put the mold into the machine, and then we can pour the material. So this process can be used for the batch manufacturing, where you want some more materials which are not available into our 3D printing platform. So we can use the combination of 3D printing and vacuum casting to produce your required material, like the polyurethane or the glass filled materials and even the nylon material. So as you can see, this is how the part is taken out, and this is a polyurethane part. So this is you can see that it simulates nearby the injection molded parts, and the density or the volume of the material is similar to the injection molded parts. So we can use the combination of 3D printing, we can use a combination of vacuum casting, and we also provide the post-processing solutions. So post-processing solutions, we provide the support removal, sanding, gluing, epoxy coating to enhance the surface finishing of the part, priming and painting where you want to make the parts more aesthetic, for the smoothing of the surface of the parts, can also be done polishing and also the electroplating. So these are some of the post-processing techniques of post-processing solutions that also we provide. Then coming on to our another applications where we provide the solutions is the healthcare. So in healthcare applications, we provide the solution to make the anatomies, patient-specific anatomies for the surgical planning, surgical training, and for the educational models, and also for the medical devices industries, where the industries can make the prototypes of the medical devices and also the anatomy to check the fitment or to check their medical devices. So you can do the anatomy testing, prototyping for the design and engineering application, and also for the another medical devices, like for the equipments that we make, like the testing machines or the diagnosis machine, where you want to start with your design iterations of product development. So for the medical devices companies who make the diagnosis equipments or the for or the testing equipments, there also it can be used. And also into the operation theater, where the surgeons require the fibula guides or the implant molds with the patient specific anatomies. So those medical devices, those medical tools can also be 3D printed and can be used, as these are the biocompatible materials and can also be sterilized into a good category. So into the medical sector, we can do the general purpose medical devices. So the medical devices product development companies or manufacturing companies, like the for the ventilator, ECG machines, glucometers, health hands, or the RT-PCR machines, or any of the diagnosis testing machines that can be used in the hospitals or in the operation theaters. So those electromechanical devices can be electromechanical device manufacturers or the product companies can use this technology. And also for the patient-specific medical devices, like I've told, we can make the patient-specific fibula guides or the implant molds, which can be which can be used on the patient into the operation theater. And these are the biocompatible and sterilizable material, and these are the certified materials. So even if you want to use with the certifications, if you require the certifications, we can provide you that. And by using those, you can move forward to use this technology, to use this 3D printed implant molds, and you can cater the patient, you can cater the surgeries in a very faster manner. So by using the 3D printing, by using the combination of our FDM and the PolyJet technology, we can make the different digital anatomies, different anatomies of the patient. So we can make the anatomies for the neurosurgeries, for the implant surgery plannings, dental surgeries, maxillofacial models, or for the maxillofacial models, cardiovascular, musculoskeletal, for the spine injuries, digestive systems, urology anatomies, and even the orthopedic models where you want to make the 3D printed bones, where you want to test out for the implant checks, or you want to study the anatomy of the patient. So this is one example. This is one of the example where we have provide the services during the COVID time. So this is a powered air purifying respirator. This is manufactured by using our Stratasys 3D printer, and this product is used for the healthcare professionals in the clinical environments. So in this solution, we have used the technology vacuum casting. As you can see, we have produced uh, uh, a small volume of the products. So we have made the patterns in the assembly technology by using the ABS-like material. And for the post-processing, we have smoothed out and the paint the part. And after doing that post-processing, we have used the vacuum casting process to produce the assembly, to produce 25 pieces. And each assembly has the 8 number of parts, and the lead time was about 1 month. The objective of making this part by using the vacuum casting was to make it leak proof, rigid enough, and user friendly. And on the functionality side, if you talk about the functionality of the final product, then this product was provided a very high efficiency, and the filter cartridge that was used was successful with the 99.99% for airborne particles. This is a few more examples, like for the handheld ticketing machine. This is onto the product side. We can use as an end use part. Different kinds of the products this into the product development. You can use this technology for the billing machine. So these are some of the examples. As for the we cannot show you all the examples that we have done because of the confidentiality clauses, but these are some of the examples. These are some of the customers or products that we have made by using the combinations of all our technologies, 3D printing, vacuum casting, and 3D scanning. So with the additive manufacturing, you get the benefits of the flexible manufacturing. You get to form the standardizations into your manufacturing capabilities. You can reduce or you can minimize your tooling cost. You can make the cost-effective, low-volume production parts. You can do mass customizations into your products. You can rapid turn your around time. You can efficiently use these thermoplastic materials that we have into our portfolio. We can reduce the design limitations. We can do more complex parts without thinking about its manufacturing side or manufacturing techniques. So we can make more complex parts. We can design, or we can optimize those designs, and we can also make the large prototypes. As you can see into our photo, this is one of the large prototypes that we can make. So we can make the prototypes even more than 1 meter or 2 meter of the parts. So the size is not limit here. By using the additive manufacturing technology, we can increase its part functionality also. So this was all about our 3D printing and our vacuum casting benefits, that what benefits that you will get and what kind of services we provide, what technology we use, and what materials we use into those categories. And then coming on to our 3D scanning and reverse engineering application, we use the most renowned, the globally awarded, and the fastest and handled 3D scanner, which is Artec 3D. This is a smart and professional 3D scanner, and it is based in the Luxembourg. And as you can see on the screen, this is a complete product portfolio that we have. So we have different 3D scanners for different applications. So let's understand that how the 3D printing, how 3D scanning technology works into our Artec 3D scanners. So we use the light or the laser-based technology. So into our scanners, we have projectors and the camera. So the projectors, it emits a light on the object, and the camera, it captures those images, and the software which we use, which is the Artec Studio software, it combines the images through these cameras, and it converts it into the 3D structure. So we scan the parts into different orientations, and the by using the technology of light and the laser, those scan data we capture into the point cloud data with the multiple scans or the single scans, and we fuse those multiple scans. If the part is bigger, we do the multiple scans and we fuse those parts, and we get the mesh data which can be exported to the STL for more post-processing applications. So this is one video to show you the demonstration of how our 3D scanner works, how our Artec 3D scanner works. So as you have seen that the handle 3D scanner, it captures the data in a very fast manner, and we can capture the data of a complete motorcycle in very few minutes. So you can say that we can scan the complete motorcycle, all the components, from 15 minutes to 30 minutes, depending upon the accuracy and depending upon the how much of the components and the precision that you want into your scans. So it just take about 15 to 30 minutes to scan a complete four-wheeler or a complete two-wheeler vehicle. And with a 3D scanner process, so this is how the workflow goes. So uh, we start from our object, okay, which is a physical object, and we use the 3D scanner. By using the 3D scanning, we get the data into the mesh, in the point cloud data, which we call the mesh also. And this geometrical entity can be used for the two categories. First is for the reverse engineering application, where you can take the reference of this scan mesh data and you can convert these geometrical entities into your final CAD files, and you can do the modifications by using the references of the point cloud data in the scan. And also you can use this for the inspection purposes. So you can, so suppose if you have a CAD design already which you have manufactured by using 3D printing or the traditional manufacturing methods, but if you want to check that how much the variations are there in between the CAD model and your final manufactured part, so you can scan the data, you can scan the final manufactured part, and you can use that scan data by overlapping to the CAD model, to its CAD design, and you can do the GD&T application for the inspection purposes. So you can use this scan data from a 3D scanner for 3D printing, reverse engineering, and for the inspection applications. This is one more example that how you can completely, that apart from the outer services, that how you can scan the inside of the automotive vehicle. Sorry, the video has a problem. But apart from that, we can do a lot of applications into very various domains. So we as an organization, we have provided and we have done a lot of services into various applications, into various domains. So we have provided the services into the aerospace, in military and defense, and also into the automobile sectors, where the 3D scanned parts, where the mesh scanned parts, as you can see, we have scanned the complete planes also, complete military and defense vehicles, heavy engineering vehicles, big vehicles like the helicopters, planes, and even in the automobile, we have scanned the complete trucks and even the tractors also. We have scanned it. So the scanner is very useful tool, and it's a very strong and powerful tool that we have into our product portfolio. These are some of the components in, you can say, the under the hood or the small components. So we can also, apart from the bigger models or the bigger objects, we can also scan the smaller objects. So we have the product categories where we can scan the object starting from 50 of the parts to 5 meters or 50 meters, or the length and the size is not a limit, even for the 3D scanner and also for the 3D printing. So these are some of the examples. These are some of the images of the scan data. And you can see that even the scan data that we get without any post processing are very smooth, and it captures all the details or the small details. As you can see that in the gear, the all fine details of the gear tools and its profile are being captured. For the car keys, that even the car keys, the small profiles and its cavities and its cuts all are scanned properly and captured properly. So we can do the scanning. We can provide you the scanning services where you want the accuracies from 50 microns to 100 microns, and where you want a very complete workflow starting from the 3D scanning to converting into the CAD model by using reverse engineering software. And also, we after converting it to the CAD model, we can 3D print those models by using our FDM and PolyJet technology. So thank you all. Thank you for all the attendees for being the patient listeners. And we can take the questions from you now. Hello. You can also write to us on our email ID, which is enquiry@altem.com. If you want to know more details about the products and the services that we have, so you can also contact to on our email ID regarding 3D printing, 3D scanning, 3D designing, simulations, and also for the vacuum casting processes. So these are the services that we provide. These are the solutions that we have. So if you have anything in your mind, so you can write to us and we can provide you the solution. Anyone has any questions? Anyone wants to know anything about our technology or services or the materials that we have? You are free to ask.